IPv6 Unicast and Multicast. So we're going to get into some more of the details on IPv6 addresses and give you greater breadth of knowledge in that. So we talked about Unicasts and Multicast addresses and things like that. So let's talk about global Unicast addresses. So for global Unicast addresses, has three parts. We have a global routing prefix, we have a subnet ID, and we have an interface ID. So the global routing prefix is the network portion of the address assigned by the provider. So that's kind of like your network address, but it's assigned by your ISP. It's currently /48s, so those are assigned to everyone. So everybody gets a /48, and it's assigned to all individuals, all companies. Everybody gets a /48. I'll put that up here actually, a /48 range. So you have an enormous number of addresses to use for every single person and every single company out there. This is why I keep mentioning that there's just so many addresses. We're not going to run out. They're not just giving everyone a specific address. You're giving everybody an entire range of addresses, and it's this huge. The subnet ID is used by organizations. So remember, we're talking about subnetting. If you wanted to do so, you could break it out into some sort of nice incremental subnet type method. So you could break up your organization like we've discussed before, but still make it easily digestible by human brains to understand. We also have the interface ID, so that's the host portion. Kind of like in IPv4, we have the network portion and the host portion. So that's a similar idea. So we have the global routing prefix as like the network portion of the address, and the interface ID as like the host portion of the address. To configure it, we'll go over this a lot more going forward, but it's basically the same as doing the IP commands that you'll see going forward in IPv4, but you just basically slap IPv6 in front of it. So normally it would be IP address 192.168.1.1 something something. With IPv6, it's IPv6 address, and then the address. But instead of defining the subnet mask in a dot decimal, you just put / whatever the range is. So for example, a command for configuration would be something like this. And then you'd write out your address, whatever it might be. I'll do something like that. So that's the basic configuration that you might do, and you'll see how that's very similar to IPv4 as we go through with that. It can also be provided dynamically. There's two methods of doing that. So dynamic addressing can be done through Slack or DHCPv6. So you have these two options, and Slack is stateless address auto configuration. So that is stateless address autoconfig. And the way Slack works is it's used to retrieve the prefix length and the default gateway from an IPv6 router without needing to use DHCP. So the idea is a client could boot up, it'll talk to its local router and get most of its information. The only thing though is it's not going to get DNS information. Remember I said it only retrieves the prefix length, and the default gateway. So it's not perfect, but it would get something up onto the network. It uses router advertisements to do that, which is a feature of IPv6. RAs. It uses these router advertisements to receive that that configuration. The router advertisements are periodically sent every 200 seconds by default, and it gets sent to the all nodes multicast group. And so these are sent to the all nodes, and that will make more sense in a minute. All nodes multicast. But if you're a client, you don't have to wait for that 200-second time interval if that's still set by default. You can send a router solicitation in order to retrieve it. So the client could send a router solicitation onto the network using the all routers multicast group, which is different from the all nodes multicast group. So it'll send it out to that multicast address for all routers saying, hey, I'm soliciting for information, and then they'll receive a router advertisement in return. So in order to enable this sort of functionality, one of the commands that we're going to have to use, which we'll clear this out. One of the commands you have to use is IPv6 Unicast routing on a router, and you will see this come up time and time again as we go through these videos here. You need to run that on a router in global configuration mode, which we will also go over coming up here, in order to turn on IPv6 functionality. So that's the main command you have to do to make IPv6 start to work and allow you to use Slack or any of the other functions. So the router advertisement will describe how to configure your device. So, but it doesn't just do that. It can describe how to configure it in different ways. So the router advertisement might say, we're going to use Slack, and here's some info. It might say, we're going to use Slack, but with some DHCP. You might say, what? Well, we'll talk about that. Or it might say, we're just going to use DHCP, and I'm not going to do Slack. So if we do Slack, we're just going to get that prefix length, and the default gateway. And that's going to be sent to the client. If we do Slack with DHCP, it's going to get that prefix length, and default gateway, but it's also going to get other parameters from DHCP, such as DNS. What DNS servers do I need? Which is kind of an odd in between there, so it'll use both, which is an interesting way to configure it if you wish to do it that way. Or it'll say in the router advertisement, we're going to use DHCPv6, and we're not going to use the Slack method, and it'll obtain all of its configuration. All of its config is going to get come from DHCP. It's going to get that prefix. It's going to get the address, the prefix length, default gateway, DNS information. You know, everything could come from the DHCP configuration. So if we use DHCP, let's talk a little bit about DHCP then. So we have this new version of DHCP, and that's DHCP version 6. It's similar to version 4, and it uses the ICMP-v6 router advertisement to describe what method we're using. So actually, when we're doing this, it's a different option in the router advertisement. So this is actually, if you look into the actual packet, it'll say option 1 or 2 or 3, and that'll define, you know, which method you're going to use. And With Slack with DHCP, which is, if you're using Slack or Slack with DHCP, the client has to determine its own interface ID, because if you notice here, it's only getting prefix, prefix length, and default gateway. So it doesn't get its own address, its actual configured interface address from the router at this point, and it only gets additional info from DHCP. So if you do option 1 or option 2 in that router advertisement, and you're using Slack or Slack with DHCP, the client has to make up its own address essentially. If you use DHCP, you can actually send it all of its information. So you could send, everything with DHCP. You could send its interface ID, its prefix, prefix length, default gateway, DNS, any other options that you want to do. If you want to stick with using Slack or DHCPv6, it's going to either randomly generate. So if we do Slack of any form, we're going to have to generate our own IP address, and it's going to do that either through a random number. It'll just randomize something, or it's going to use EUI-64. And if we use EUI-64, what that stands for is Extended Unique Identifier. And what you do with that is it takes the 48-bit MAC address from the client, and we'll talk about MAC address coming up here when we get down to layer 2. That'll make more sense, but it's a 48-bit address for your Ethernet network interface card. And so that network interface has, a specific address burned into it. So it'll take that address and it cuts it in half. So you'll have a 24-bit OUI, which defines like the manufacturer, and then you'll have a 24-bit the 24-bit device identifier. And then in between here, when it cuts it in half, we're going to have something stuffed inside here. So what it's going to do is it's going to insert 16 bits, and they're going to be FFFE. So that'll be our 16 bits that get stuffed in between there. So if you ever see an IPv6 address that looks like that with FFFE in the middle, that's where it came from essentially. And it's a easy way to automatically create a unique address with using something that's already usually quite unique, your MAC address. At least it should be unique. You could take that and stuff some bits in between, and then you magically get an IPv6 address. So let's talk a little bit about some other types. Let me clear this out. We'll just erase. Okay, so let's talk about dynamic link local address. Remember we were talking about link local addresses at one point? You can do it dynamically by creating, it's created using the FE80/10 prefix and the interface ID, which we determined earlier. You can also do a static You can also do it statically, and in order to configure it statically, you'll do it almost the same way as you saw that command before, which we'll go over this again in future videos, but you'll do IPv6 address, and then you'll define link local so that it knows you're not doing the global unicast address. So link local, and then whatever IPv6 address you're going to have there. To verify some of this configuration, we'll go over this a lot in the next video or so, and as you see going forward, but a couple commands you want to know as well when we start getting into these actual routers is a show interface. That'll give you a ton of information about whatever interface you have configured. It'll give you a ton of information. You also have show IPv6 interface brief and show IPv6 route. That was a terrible 6. IPv6 route. And that'll give you a bunch of information. The show IPv6 interface brief will give you just a basic overview of what interfaces are configured and what their interfaces IP addresses are. Show IPv6 route will give you all of your routes in your route table, which we'll see for IPv6. So one thing that we haven't really talked too much about in detail are the multicast addresses. So let's blank out some of this. And let's talk a little bit about multicast. So IPv6 multicast have the prefix of FF00/8. So it's a very large range. And there are different types of multicast addresses that are predetermined within IPv6, and we mentioned them earlier with such as all node and all router. So there's reserved addresses within this multicast that's not just for applications and such, but different IPv6 devices will join certain multicast address groups within this range by default. So not just specific protocols, but also just because they are IPv6, they're going to join these. So one of these is all nodes. We also have all routers. The all nodes multicast group, all IPv6 devices join this. And we have all routers. And guess what? All IPv6 routers join the all routers groups. Makes sense, right? So let's write out what their prefix is. So remember, it starts at FF00, so we have FF02::1, and we have FF02::2. So remember, double colons means we have all zeros in between there. So it's going to be FF02, a whole bunch of zeros, 1. FF02, a whole bunch of zeros, 2. So that's the two multicast groups that are commonly used. You have the all nodes and the all routers groups, and they are commonly used in IPv6 for a lot of functionality, like we mentioned with the router advertisement and router solicitation packets. Those are sent using these addresses. There's also solicited node multicast. It'll match only the last 24 bits of the IPv6 global unicast address, and that is FF02, as we see here, a whole bunch of zeros, but then FF00 at the end, plus the last 24 bits of the unicast address, but we're not going to go into detail on that. So from here, what we'll do is go into a little bit about testing IPv6 connections. We'll talk a little bit about ICMP and some different troubleshooting techniques you can use to test IPv6, which will also apply to IPv4, which we'll see.